Hi, today we will solve a few problems related to the time response analysis. The first problem is a transfer function is given as 1 by s plus 2 and the system is excited by input of 10 ut which is a unit step multiplied by 10. Now we have to find out the time taken by the system to reach 99% of the steady state value. And the second problem is since it's a first order system, we will derive the rise time of the system. So we'll start with the time domain output analysis. Um, so input in S domain is input in S domain is 10 by S, and output will be transfer function multiplied by input, which is 1 by S plus 2 cross 10 by S, which we can write as 5 by S minus 5 by S plus 2. Okay, now the output in time domain is inverse Laplace transform. Five by S minus 5 by S plus 2, which is first term is 5 again, and second term is exponential term 5 e to the power minus 2t, which is 5 into 1 minus e to the power minus 2t. So what is the steady state value of this signal? Steady state output is 5 into 1 minus e to the power minus infinity, which is 5. So if I draw that output on time domain, you can see it's interesting. So the input is a unit step of 10. So if this is 10, steady state value is only half of it. And that also it reaches exponentially. So this is the step response of the given transfer function in time domain. Now we'll come to the actual problem. We have to find out the time taken by the system to reach 99% of the steady state value. So we'll again start with this thing. 5 into 1 minus e to the power minus 2t goes to 99% of the steady state value. That means e to the power minus 2t is equal to, just cross this, t is equal to and negative of that, which is nothing but log 100 is 4.6, that divided by 2 is equal to 2.3 second. Now second part is to compute the rise time. Now rise time can be written as TR is the time difference between 90% and 10%. So for this time taken to reach to 90% can be written as similarly time taken to reach 10% is half. Okay, so rise time is finally which finally can be written as half. Now log 9 is approximately 2.2 by 2 is equal to 1.1 second. The second problem is transfer function of the system is given as 1 by 2s plus 1 and the system is excited by a unit ramp. What is the steady state error? We will try to find out the steady state error, time domain steady state error from the frequency domain itself. So let us see what is the input in Laplace domain. This is 1 by s square, okay, and output is 1 by s square into 1 by 2s plus 1. Okay, now steady state error, first of all error signal is defined as us minus ys, which is 1 by s square minus square into 2s plus 1. This part we can simplify as 1 by s square minus 2 by s plus 4 by 2s plus 1. If we just try to write the denominator, this will be 2s plus 1 minus 2s into 2s plus 1 plus 4s square. Now 4s square term gets cancelled by this, 2s term gets cancelled by this, finally numerator is 1. Okay, which can be simplified as 2 by s minus 4 by 2s plus 1. This is the error signal in S domain. Now we will use the final value theorem, which says steady state error is t tends to infinity yt, which is nothing but s tends to 0 S into, sorry, this is error in time domain. So this is nothing but S into ES, okay, which is S tends to 0, S into 2 by S minus 4 by 2S plus 1 is equal to 2 minus 0. So this is the steady state error. And you can see we have not used the inverse Laplace transform. We have not derived the time domain response at all. The third problem. Third problem says the step response of a system is given as Ct is equal to 1 minus e to the power minus 2t. What is the transfer function of the system? So again, the output of the system is given in time domain as 1 minus e to the power minus 2t. We need to find out the output in Laplace domain first. So Cs is equal to Laplace inverse, sorry, Laplace transform of 1 is 1 by S, and then that e to the power minus 2t is 1 by S plus 2. So the output is S plus 2 minus S into S plus 2. If we share, this is 2 into S plus 2 into S. This is the output. Now transfer function by definition is given as equal to output by input. Okay. Now input here is step, which is 1 by S. So transfer function is 2 by S plus 2 into S into S. That means transfer function of the system is 2 by S plus 2. So again, from the time domain output, we can find out the transfer function. That's all for today. For more problems and exercise, please follow our website and the WhatsApp group. Bye bye.